This is Rebecca from chemistryismyjam.com. In this video, we're going to be talking about isotopes and learning to calculate average atomic mass. Let's begin by talking about what an isotope is. Atoms with the same number of protons but different numbers of neutrons are called isotopes. I have two different versions of nitrogen drawn for you on the screen. Nitrogen is element number 7 on the periodic table. It has an atomic number of 7, so nitrogen must have 7 protons. And in both of these examples, if you count the positive charges in the nucleus, there are 7 protons. However, the number of neutrons can vary for nitrogen. This one over here has 7 neutrons, and this one over here has 8 neutrons, and that is totally okay. Those are two different isotopes of nitrogen. So the number of protons is dictated by which element you're dealing with, but the number of neutrons can change. So now that we know what isotopes are, and that there can be multiple types of atom for each element, we need some way to represent that. We need some way to let our readers know which type of atom we're referring to. So there are two common ways to write isotope symbols. In the example on your screen, I've written carbon-14 two different ways. The first time I've written the word carbon -14, and that 14 represents the mass number. That is the number of protons plus the number of neutrons. Notice that I did not tell you the number of protons because if it is carbon, it must have 6 protons. You can look at the periodic table and find that number. Another way that we can write that is to use the symbol for carbon, so that would be a C, and then I would put the atomic number on the bottom. You can find that on the periodic table, and it is the number of protons. And then on the top, I have the mass number, the number of protons plus neutrons for that particular isotope of carbon. Both methods of writing out isotopes give me the same information. They both tell me what element it is, which means that I can use the periodic table to determine the number of protons, and they both give me the mass number, and if I know the mass number and the protons, I can determine the number of neutrons. Here you have some isotope symbols that we're going to use to practice determining the number of protons and neutrons. Our first example is oxygen-16, where 16 is the mass number. I can also see from this version of the isotope symbol that it has an atomic number of 8 because the bottom number tells us the atomic number. That also tells us the number of protons. Protons will always match the atomic number. For the number of neutrons, recognize that the protons plus the neutrons must equal the mass number. So if you take the mass number and subtract the protons, you can get the neutrons. 16 minus 8 tells me that there are 8 neutrons in that particular isotope of oxygen. The second example gives me the atomic number and the number of protons. So I can look at the periodic table and find element 30 and determine that that is zinc. So we know that we are dealing with an isotope of zinc. That goes in both of the isotope symbols. We also know that the atomic number is 30, so I can go ahead and fill that in here. That atomic number matches the number of protons, so we know that there are 30 protons. At the bottom, it tells me that there are 35 neutrons, and we know that the mass number is the protons plus the neutrons, so 30 plus 35 is 65. So now we know the mass number that we can fill in all 3 places on the chart. Our last example is sodium-22. Looking at the periodic table, you will find that sodium has a symbol of Na, and it is element number 11 on the periodic table, which means that it has an atomic number of 11, and it has 11 protons. This particular isotope of sodium has a mass number of 22, and we can use the mass number and the protons to find the neutrons. Mass number minus protons gives me neutrons. So this isotope has 11 neutrons. Recall that mass number is slightly different from the number that you see on the periodic table. Mass number is for a particular isotope of an atom. Mass number is protons plus neutrons. The number that you find on the periodic table is the average atomic mass. Average atomic mass considers all of the different isotopes of a given element, and it is a weighted average, so the isotope that is more common factors more into the number. For example, copper has two very common isotopes. There's copper with a mass number of 65 and copper with a mass number of 63. Those are represented over here. And if you were to count, you're going to find 7 copper 63s and only 3 copper 65s. So the copper 63 is more common. That indicates to me that the average atomic mass for copper is going to be closer to 63 than it is to 65, because copper 63 is more abundant. Calculating the average atomic mass is very much like calculating your grade in a course. Average atomic mass is a weighted average, just like your grade is a weighted average. Typically, tests count more than homework or classwork. In this example, tests count 50%, homework is 30%, and labs are 20%. And we're going to calculate the overall grade for this particular person. The first thing I'm going to do is turn those percentages into decimals by moving the decimal 2 places to the left. So 50% became 0.5, 30% became 0.3, and 20% became 0.2. Then I'm going to multiply those percentages by the grade for that section. So when I said 0.5 times 92, I got 46. 0.3 times 76 gave me 23, and 0.2 times 95 gave me 19. The last thing I want to do is add these 3 numbers together, and that will give me the grade for the course. This person currently has an 88 in the course, and you can see that that 88 is closer to the test average than it is to the homework average because tests count more. It is a weighted average. We're going to use very similar steps to calculate average atomic mass. In this case, we're studying copper, which has 2 common isotopes, but you could apply this process to something that has more isotopes. In order to calculate average atomic mass, you need 2 pieces of information. You need the mass for each isotope, and you need a percent abundance. Of the total element, what percentage is the isotope that you're looking at? So that's what percent abundance means. We want to follow these steps where we're going to convert the percentages into decimals. You're going to do that by moving the decimal 2 places to the left. Here I have converted both of the percentages into decimals. Notice that I kept all of my significant figures and just moved the decimal 2 places to the left. Now I'm going to follow step 2, which is where you multiply the mass by the abundance. You can see where I took the mass of copper 63 and multiplied it by the percent abundance for copper 63, giving me a 43.52. I repeated that process for copper 65. The final step is to combine all of your answers. So I'm going to be adding together 43.52 and 20.03, which gives me 63.55. That is the average atomic mass for copper. Notice that the most common isotope of copper was the one that was 69%, and that is copper 63. So I expect my average atomic mass to be somewhat close to the most common isotope. And in this case, you can see that 63.55 is closer to 63 than it is to 65. So this is a weighted average that considers the most abundant isotope more. You can also check yourself because 63.55 should be the number that is printed on the periodic table for copper. So in this video, we've covered isotopes and average atomic mass. Stick around while we look at ions in the next video.